right, hello Megan and whoever else is watching this. We are starting 9-1. This is about right triangles and stuff. Here we go. All right, so this is the beginning of trigonometry, which is the study of angles, basically, in a triangle. Okay? Now, I just threw out that, like, mnemonic device to you, and I said SOHCAHTOA. Write this down. S-O-H-C-A-H and T-O-A. I purposely make the S, the C, and the T bigger. So, try to do the same. S-O-H-C-A-H-T-O-A. SOHCAHTOA. Okay, you're going to know what this thing means. You're going to use this a lot. SOHCAHTOA. All right, so here's the deal. We have a right triangle. This is my right triangle. And this right triangle has vertices that are called A, and they're called B, and they're called C. And that doesn't really matter what they're called. Okay? When we're doing SOHCAHTOA, we are always looking at one of the angles, but it's never the 90-degree angle because he's boring. We know what he is. We know he's 90 degrees. We don't know what B is, so we're going to either look at B or look at A. And in this case, we're looking at B because he has a little symbol right here that's like a circle with a line through it, and it is called theta, T-H-E-T-A. It is a Greek symbol, and theta is just like X or Y or Z. It's just a variable, but they use it to represent an angle a lot of times instead of using X, Y, or Z, right? So they use theta, but don't let that confuse you. It's just like a variable X that we don't know. We don't know what angle theta is. Maybe it's 40 degrees, maybe it's 80 degrees. We don't know. We're going to figure out what that is, okay? So today we're only going to be like writing out the relationships of sine, cosine, and tangent. Tomorrow we're going to be solving for some things, okay? So now the next thing is if we're looking at B, not A, we're not looking at A, we're looking at B, we have three sides of this triangle, okay? We have an opposite side, which is this guy. Do you see where he's opposite? Okay? We have to identify which one is the opposite side. Now, the opposite side is the one opposite the angle. Okay? Now, sometimes it's hard to identify the opposite side, so if you have a weird shaped right triangle where it's hard to identify, I just look at it like this side touches angle B and this side touches angle B, right? The opposite side will not touch angle B. True? He will be opposite, okay? So it's the only side that doesn't touch my angle that I'm talking about, okay? Now, the hypotenuse side, have you heard the word hypotenuse before? Yep. Yes? Okay, the hypotenuse side is the longest side. It is the one that's opposite the right angle. True? Yep. Now, every year in my geometry class or even in your class, I'm pretty sure one of your homework assignments is listed like this. They do this to you. You don't have to draw this, okay? But they do this and they say, which one is the hypotenuse side? And more times than not, people say this one because it's the slanted one. Which one is the hypotenuse side? The bottom one, right? This is the biggest side, not this one. So don't go by like it's the slanted side because when they position it like that, the hypotenuse is actually the bottom in that case, okay? So be careful because they kind of hide that from you a little bit, all right? The third side is a side that's called the adjacent side. So I label him with an A. And the word adjacent means right next to. Okay, the word adjacent means right next to. So like my room is adjacent to Mrs. Ruth. My room is adjacent to Mrs. Bokelman's room. It's adjacent, they're right next to. Now, technically there are two sides that are adjacent to my angle, right? Aren't those two sides both adjacent? But one of them is the hypotenuse already. So that one takes precedence. So the hypotenuse is also technically adjacent, but because he's labeled as the hypotenuse, we only go with that. We just label him as the adjacent side. Got it? Yeah, got it. So we have hypotenuse, opposite, adjacent. That is where these letters come from in the SOHCAHTOA stuff. Got it? All right. Now, the capital letters, S, C, and T. Here we go. The S stands for sine. Write that down. S-I-N-E. The C stands for cosine, C-O-S-I-N-E, and the T stands for tangent. So sine, cosine, and tangent. Have you heard those words before?
I've heard of tangent.
You've heard of tangent? Probably a different tangent, though. Yep. Tangent is a widely used term in other things besides just math. So sine, cosine, and tangent. And even in math, tangent has like 4 different meanings to it. In math. So sine, cosine, and tangent. All right, on your calculator, you have buttons for sine, cosine, and tangent. We won't have to be using your calculator too much today. We'll be doing those calculations tomorrow, but if you want to find those buttons on your calculator, you can. Sine is abbreviated S-I-N. Here is my pet peeve. Are you ready for this? I don't like it when people call it sin because I have no idea what you're talking about other than like you're going to hell, right? Like that's what I think when you say sin, okay? Definitely. So still pronounce it sine, even though it's abbreviated S-I-N, okay? This one is abbreviated C-O-S, but don't call it cos because I have no idea what you're talking about. It is still pronounced cosine, even though it's abbreviated C-O-S. And this one looks like T-A-N, which is tan, but I'm going to think you're laying in a tanning bed if you say tan, so call it tangent still, okay? Got it? All right, so here's the deal. Now, the next piece of this is sine, cosine, and tangent. What will immediately follow sine, cosine, and tangent is the angle that we're talking about. So we're taking sine like of theta, cosine of theta, and tangent of theta. Right? Immediately following sine, cosine, and tangent, we have to talk about the angle that we're talking about, right? And then we say equals. Okay, so sine, cosine, and tangent equals. And then all we're going to do is a ratio. So it's going to be like something over something and something over something, right? All right, so here's the deal. Here's what we do. Because we have this mnemonic device, SOHCAHTOA, this tells me what goes over what. So sine is O and then H. Do you see that in my SO? That means O goes on the top and H goes on the bottom. Does that make sense? So, so the deal here is if I go back to my triangle, let me erase some stuff here, okay? We have O and then H and then A and all that good stuff. Let's say that this side is 3. Let's say this side is 4 and this side is 5. I'm just going to make these numbers up and slap them on this triangle. If I say that sine is O over H, it would be what number over what number? O is 3 and H is 5, so it would be 3 over 5, and that's what sine of that angle would be. Does that make sense? That's all we're doing, okay? Cosine is A over H. Do you see where it says the C-A-H? A goes on top, H goes on bottom, so what's the A value that I have on my triangle?
Call me. Shh. Yeah.
Oh my goodness.
We got it for our favorite color.
You are so crazy. Oh my goodness. Oh my goodness.
The one that has the most potential.
Sure. This one that has the most potential? Okay.
Woo.
Yeah. All right, so what's A over H going to look like for this triangle? What's A? 4. A is 4, and 5 is the hypotenuse, right? So that would look like 4 over 5. Got it? Tangent is OA, opposite over adjacent. So O over A, what's O over A look like? 3 over 4, right? Like it's just making these fractions. Okay, make sense? Okay, now, it doesn't seem like we're solving for anything yet, because we're not. We're just listing the ratios and how the SOHCAHTOA stuff operates. But tomorrow, what we'll be doing is we'll be using those numbers and the values of sine, cosine, and tangent in your calculator to actually find, like, how many degrees is angle B? We can use that information and those buttons in your calculator to do that, right? Yeah. So it's not going to feel like we're doing a whole lot today, but making fractions, because that's what we're doing. But we got to get used to the pattern of the SOHCAHTOA stuff, okay? So let's go to our first example, which is down here. And example 1, it has sine, cosine, and tangent, and then it has these other 3 things. We're going to talk about them here in just a second. So let's do this sine, cosine, and tangent stuff first, okay? So we've got these guys going on, and we got to create our, stuff, okay? All right, so going over here, do you see where angle theta is located? Angle theta is down here in the corner. Circle him, okay? So you know, your eyeballs go straight to that. All right, which one is the opposite side? 8. So label him with an O. Which one's the hypotenuse side? 17. Which one's the adjacent side? The only one that's left, right? Okay, can we identify those? Those are good to go? Okay, so now we have to make our fractions. So we have SOHCAHTOA. Okay, SOHCAHTOA. Rewrite him or refer to the top if you need to. For sine, O comes first and then H. So it will be what over what?
8 over 17.
8 over 17. That's it. Okay. Cosine is AH. That will be 15 over 17. And tangent is OA. 8 over 15. Questions about that? Okay. Then tomorrow we'll eventually use those to figure out what the angle is. Okay. Now, let's talk about what these guys are. These guys are what's called the reciprocal functions. Okay. And the way that I think about them is that they are the married couple to the ones on the left side, okay? So this guy right here is called cotangent, okay? It would make sense that tangent and cotangent would go together, true? That is like his married partner. Those two things are married, okay? This middle one is called secant, S-E-C-A-N-T, and this one is S-E-C-A-N-T, right? That's what those guys stand for, and that's how they're abbreviated, okay? So cosecant, secant, and cotangent, got it? And they are married to the other ones. Now here's the thing that I don't agree with. It makes sense for tangent to be married to cotangent. That makes sense, like that's a thing. But what would make sense in my mind is for cosine to be married to cosecant. And whoever came up with this like an infinity ago screwed up, because cosine does not go with cosecant. Cosine goes with secant. The C goes with the S, and sine goes with cosecant. So S and C go together, and S and C go together, instead of doing it the non-stupid way and doing it the way that they should. So I apologize for the confusion. But sine, this S goes with this C, and this C goes with this S. Does that make sense? Like that's just the way that it goes. Why do I have so many people in here? What? What do you want? 10-3. Do you have the notes for 10-3? We did the first half of 10-3. I did. I just have to send it to you yet. It's not. I haven't sent it yet. So there's that. Okay, good? Does that make sense? S and C go together, S and C go together. Okay, now here's how they operate. If sine is 8 over 17, what do you think cosecant is? 17 over 8. That's the way that it operates. They're flipped of each other. Okay? Cosine is 15 over 17. Secant is going to be 17 over 15. And the bottom one will be 15 over 8. Make sense? Kind of. I mean, yeah, like as much as it can make sense. Okay? All right, so there you go. That's SOHCAHTOA stuff. All right, now let's do some more. This bottom part is talking about more about the reciprocals and saying that cosecant and sine are like the flip of each other, right? So, in other words, cosecant is 1 over sine, or you just take the fraction and you flip it, right? That's what a reciprocal is. You take it and flip it, right? Same thing for secant and cosine, and same thing for cotangent and tangent. You just flip them, okay? All right, we're going to do one more example, and then we'll stop, and I'll tell you what to do for homework, and you'll be good to go, okay? This one's going to give you a little bit different information and be a little bit harder. So here we go. They don't have any of this labeled with sides at all. Okay? But they tell us this stuff right here. Sine of B is 5 over 8. So which angle are we looking at? We never look at C. So we're looking at A or B. We're looking at B. B is like my angle theta. Okay? So that's what we have going on there. B is angle theta. That's the one we're looking at. So I put a circle around him. Okay? Now, it says sine of B is 5 over 8. Okay? What is sine? What over what is sine? O over H, right? Sine is SOH. Okay? So that means the opposite side is 5. The hypotenuse side is 8. Okay? Which side is the opposite side? The up and down one. This one's 5 right here, right? That's the opposite side, okay? The hypotenuse side is 8. Which one's that one?
The long one.
The long one. H is over here, and that is 8. And that's all they give me. Ugh. I need to know the third one, though, if I want to do all of them, right? How do I do? You're so brilliant. This is a right triangle. A squared plus B squared equals C squared. What is that thing called? That's the Pythagor. I think that's how you spell it. The Pythagorean theorem. Okay, little tidbit about the Pythagorean theorem that you maybe didn't know. It is named after an old dead guy with the last name of Pythagoras. Have you heard that before? Okay, who is credited with coming up with this formula that is so brilliant that we use a lot. And he did not actually come up with it. Did you know that? He was dumb and rich. And somebody else was poor and smart, and they came up with it, and he bought it from them so he could have his name attached to it. Isn't that awful?
That's awesome.
Ah,
And he bought it.
yeah, I mean, you know, whatever. So like some dumb, like some smart poor guy that we will never know the name of actually came up with this theorem, and we, you know, whatever.
He was smart enough to buy it.
It was smart enough to buy it, I guess. So the Pythagorean theorem, there you go.
Cry about it.
A squared, B squared, C squared. Okay, let's find out what the third side is now. When you do A squared, B squared, C squared, Your C has to be the longest side. Are you listening? Your C has to be the longest side. So in this triangle, what's my C value? Which one is C? 8 has to be C. 8 is the hypotenuse. C is always the hypotenuse. Toby, did you hear that?
Yes.
Okay, the hypotenuse is always C. So 8 squared goes here. Now, 5, do you want that to be A or B? Does it matter?
No.
No. So let's go 5 squared plus B squared equals 8 squared. All right, let's figure out what the other one is. What's 5 squared? 25 plus B squared equals 64. Now let's take and subtract 25. So B squared equals like 39, I think. Is it 39? Yes. And then how do we find B? Take the square root. The square root of 39 comes out as a decimal, so we're going to leave it as the square root of 39. We don't put it as a decimal. We don't put it as a decimal. Now, is that opposite hypotenuse or adjacent? Adjacent. We already have an opposite here, kid. It's right there. That's the adjacent side. True? Yes? Okay. All right, let's do our SOHCAHTOA. SOHCAHTOA. Here we go. Sine, cosine, tangent, cosecant, secant, cotangent. Here we go. Sine is opposite over hypotenuse. What's opposite over hypotenuse? 5 over 8, just like they told me up here, right? Sine was 5 over 8. That's what they gave to me. So that means cosecant is 8 over 5. If we flip them, okay? Cosine is AH.
Square root 39 over 8.
A is the square root of 39, and H is 8. So then we have 8 over the square root of 39. Got it? Tangent is OA. So 5 over the square root of 39, or the square root of 39 over 5. Now, we're not done yet. There's one more thing that you're not going to like a whole lot. But you've heard like mixed numbers and improper fractions, right? Okay. In the square root or the radical world, it is considered to be improper if you have a square root in the bottom. So which one of these are improper? Tangent and secant. Those ones are considered to be improper, which means we have to fix them.
Like just find the
We have to fix them. So we're not gonna make it into a decimal. Here's how we fix it. Are you ready? Are you watching? This is the hard part. We multiply him by the square root of 39 over the square root of 39. Okay? And the reason why we do that is because what does the square root of 39 over the square root of 39 reduce to? That's like multiplying him by 1, right? The square root of 39 over the square root of 39 is 1. So I'm just multiplying this thing by 1, okay? Now, if I take the square root of 39 times the square root of 39, it is like the square root of 39 squared. What happens when you square a square root? It just ends up being 39 on the bottom. Do you see how that works? Okay? Then what is 5 times the square root of 39? 5 square roots of 39. The 5 is on the outside, the 39 is on the inside, so we can't put them together. We just write it like that. Okay? All right, we're going to do the same thing for secant. Okay, I'll zoom out. We're going to multiply by the square root of 39 over the square root of 39. Okay? So on the top, it becomes 8 square roots of 39 over 39. That's it. That's how you fix it. Okay? Not too bad. Not terrible. So any of those ones that have a square root on the bottom, that's how you have to fix them. Got it? Okay, that is all I have. That's where we're going to stop, but I'm going to tell you what homework to do. Are you ready? Okay. Do 1, 2, 3 and 1, 2, 3. On both sides. 1, 2, 3 and 1, 2, 3. Okay, now the pain in the butt part is that you have to do sine of theta, cosine of theta, tangent of theta, right? Then you have to do cosecant of theta. You have to do secant of theta. And you have to do cotangent of theta. You have to do all 6 of them for each problem, which is a pain in the tushy tush. Right? Okay? So there is that. Got it? And you'll have to do Pythagorean theorem to find out what the third side is. Poop. Okay? All right. You are probably going to get stuck on number 3 on practice because it has a square root in there. But we'll save that one for tomorrow. So just so you know, number 3, if you run into a little, like weird thing, we'll work on that one tomorrow. Okay? Got it? So there you go. 1, 2, 3, 1, 2, 3. Get a start. Any questions? Okay.